All right, so acid bases. Here's the thing. You don't have to know fixed acids and organic acids and volatile acids, really. I mean, go ahead and read it if you want. That's awesome. But again, I'm not trying to teach you everything about acid bases. Okay? What I want you to know about acid bases is this little formula. You will see it come up several times in this 27 slides. Okay? But you need to know this thing and you need to understand it. Okay? This isn't chemistry class, but this little chemical formula is definitely going to help you understand acid bases. The whole point of acid bases is this formula. Okay? So first thing I want to point out is right here in the center, you have carbonic acid.
Does it help when I turn off that light?
Yeah.
Okay, all right.
Okay, so that first thing you're going to see is carbonic acid in the center. Notice, you're going to be able to see it from the back, but these arrows go both ways. Okay, this is a reversible reaction, as in it can shift one way or the other depending on what it needs to do to maintain your homeostasis in your blood. Okay? Still with me this far? Okay. Now, one thing I need to point out is that when you are taking acid bases, you're taking them from your bloodstream. Okay? Where are you taking that blood sample from? Arteries or veins?
Veins.
Exactly, arteries. Okay? This is like the only time that you will probably ever think about sticking a needle in an artery. Okay, maybe a central line or something, but I don't think nurses do those. Actually, I don't think nurses actually do arterial blood gases either, because it's not like the normal, stick it in like that at an angle. It's, you take that wrist and you shove that sucker straight in until you hit that radial artery. I've done it several times, and I got to tell you, every time I'm shocked that it worked, because you can't see the artery. You're going, okay, this is anatomy, this is where it should be, and you just shove her straight down in until you get bright red blood, and then you hope your hand doesn't collapse and go like this.
Oh my God.
It does happen sometimes. It never happened to me. But, so you're getting arterial blood. Therefore, they call this arterial blood gases, or ABGs. Okay? So, because you are pulling out blood out of the arteries, and it's arterial blood gases, you're going to get different numbers than if it was coming from veins. All right? So, you need to know these normal numbers. Okay? For pH, our normal number is what? Human blood is
3, 5.
7.35 to 7.45. Sometimes we'll just use 7.4 for simplicity's sake. Okay? That's normal. You need to know that. Okay? I probably won't even give that to you on a test. Just, you need to know it. Okay? Your CO2 level. Normal CO2 level in human blood is 35 to 45. Okay? Notice I'm not putting units in here. You can see them later. I don't really care. It should be 35 to 45. Okay? Your normal bicarbonate level in your blood, this tends to vary if you look it up on the internet, but we're going to go with 22 to 28. Okay? You need to know those numbers. Okay? All three of them. Probably not going to give it to you. Got it? Okay. Get it? Get it. All right. So, let me continue back to this formula. All right? I'm going to take this formula and I'm going to draw a couple different things on it. One, I'm going to take this left side of the formula where it has CO2, carbon dioxide, and water, and I'm going to make a big lung on it. Yay? Okay. Okay. So I made a lung. Why? Because CO2 can exit out the lung, right? I mean, that makes sense, yes? We know that. Carbon dioxide, you blow it out, leaves your lungs, right? Okay? Because CO2 exits out the lung, or not, right? It might decide to just, let me redraw that blood thing down here. It might just decide to stay in the blood, and if CO2 decides to stay in the blood, right, then you're gonna have more CO2 in your blood, right? So how do you think you can get CO2 either out of your body or stay in your blood? What do you do to make a difference?
So you blow off CO2.
Yeah, you either blow it out or you don't, right? So what would happen to your CO2 level in your blood if I'm doing this?
So you become more alkalytic.
Okay? I'm gonna blow out all of that CO2, which means CO2 is not in my blood, right?
Yep.
Now CO2, now hang with me on this one. CO2, I'm gonna call acid. Why? Because if I blow CO2 out of my lungs, I am taking this entire reaction, shifting it left, and with that I am drawing out these acids so that they can balance out back in equilibrium, which means literally I'm indirectly blowing acid right out of my lungs, right? So for the purposes of acid bases and understanding them, think about CO2 as acid. Got it? So if I hyperventilate, my blood is going to be what? If I hyperventilate, get rid of a bunch of CO2,
So you'd be more basic?
which is acid, what's going to be left in my blood is not acid,
No.
right? What's going to be left in my blood is not acid. Therefore, my blood will be more basic if that's what I'm doing, right? Does that make sense?
C.
Okay, because of that, you can say that this respiratory system, we're all in agreement that CO2 is controlled through a respiratory system?
C.
C. We can agree that this respiratory system can either make your blood acidic or it can make it basic depending on what you do with CO2, also known as acid. With me on that? Okay? So we could have an acidosis or an alkalosis, which means the same as base, by the way, based on how much CO2 we blow out or we don't blow out, right? How would you not blow out CO2?
By holding your breath.
You hold your breath, okay? There are about 1 billion ways to hold your breath, right? You can hold your breath. You can, that's funny, my daughter right now, she's, I told you, she's in her 4th block of nursing school right now at GCU. And she was in the Osborne emergency room last weekend, and she sends me a text. It's like, something like, LOL, some guy just brought his girlfriend in because they got in an argument. She held her breath and passed out, so he called 911.
What?
I didn't think that happened in real life.
You know what? Have any of you guys ever, when you were a little kid, held your breath so much you passed out? On purpose because you were throwing a fit?
Breath. Never.
It's always one. That is one stubborn kid, right? To do it long enough to hold, to pass out, you are the most stubborn little booger. But that's good, because you kind of need that stubbornness to get through a lot of life, right?
Yeah.
Anyway, so yeah, that can happen. You can literally hold your breath. You can have conditions like asthma, bronchitis, edema. You could be drowning. Elk could be choking you. I mean, whatever. If you're holding your breath, you're not getting rid of CO2, so it's staying in your blood, right? Okay. On the other side of this little balance thing, I'm going to take that and I'm going to draw a kidney. Okay, why? Because the kidney has the same options with bicarbonate. Okay, bicarbonate is a base. Okay, sometimes you hear it called a buffer because it buffers acids. It's neutralizing acids, right? So bicarbonate is a base. Okay, exactly opposite of acids. So the kidney, depending on what it needs to do, can take that bicarbonate and stick it back in the blood, or it can decide to stick it in the urine, right? Does that make sense? So if the kidney decides to stick bicarbonate back in your blood, and that's the only thing you know, what is your blood going to look like, acidic or basic? Basic, right? You add more base, you get alkaline blood. Yes? What if that kidney decides to urinate out your base, your bicarb? What's your blood going to look like?
More acidic.
More acidic, right? So again, this can cause an alkalosis or an acidosis by what bicarb does also, okay? The reason I'm making kind of a specific point about this is because whether it is the respiratory system or the metabolic system, whether it's CO2 or bicarb, whether one of them's an acid and another the base, they can both cause an acid or base problem, okay? By having too much or too little in your blood. Okay, so it's the exact same thing. Believe it or not, that's almost everything you need to know about acid bases. Okay? It really is that straightforward. Now, you'll notice that I took a couple of liberties for simplicity's sake. Okay? For example, bicarbonate is controlled in the kidney. It's actually made in the pancreas. Okay, fine, whatever. That's still part of your metabolic system, right? Okay? When you have an acid-base problem and the kidney's trying to fix it with bicarb, okay, maybe it's urinating out bicarb, but maybe at the same time, it's actually taking the hydrogen acid and sticking that back in your blood. Or maybe it's doing the opposite, right? The reason I want you to notice this, but then forget about it, is because I don't want it in your head that the metabolic system deals with acids. What I want it in your head is the metabolic system deals with bicarb, which is a base. The respiratory system deals with CO2, which is an acid. Okay? Otherwise, you just might get confused. Obviously, it's true. Everything's always in homeostasis and everything's going back and forth, but it makes it simpler if you think about it that way. With me on that? C. Okay. The other thing that you would have to know, you know what, let's save that for now. Let's throw some numbers out there, shall we? All right, so we have a patient. Now let's just go with hyperventilating, right? It was midterms. Alex didn't get a study guide, so he's hyperventilating. Right?
So he's more basic.
What is Alex pH in his arterial blood going to be?
7.45 or higher.
It's gonna be 7.
Yep.
Well, the normal range is 7.45.
It's going to be 7 point something more than 4.5, right? Let's just say 5 just for simplicity's sake. Why? Because he blew out all of his acid, therefore he's left with base. So if we have a pH, and that's the only number that you know, you can go ahead and say we have a alkalosis, right? We can say that, yes?
Yep.
Because it's true. That's the definition of an alkalosis, more than 7.45. Okay? Next, I'm going to look at CO2 levels in his arterial blood. Okay? CO2 levels, what do we need to make that to be consistent with a alkalosis caused by hyperventilation? Okay? I heard the number's 30-ish.
So you
Why?
need,
Because that's less than 35, right? And if it's less than 35, you do not have enough acid. If you do not have enough acid in your blood, and that's the only thing you know, right? Forget I said anything about pH, hyperventilation, midterms, nothing, right? All you know is somebody has a CO2 of 30. Is that one thing alone? What is that going to do to your blood? If your CO2 level in your blood, arterial blood gas, is 30, what is that one thing, that one fact, what's that going to predict your blood is going to look like?